Algebra 2, Lesson 1.6, Part 1 of 2. Absolute value equations. Before we begin solving these first two equations, we need to discuss what is an absolute value equation. The absolute value asks us how far is the number from 0 on a number line. So if we were to take the absolute value of 3, we would know that it's 3 units from 0. And the same thing is true of -3. It is also 3 units from 0. So we're going to be reversing that and asking ourselves, for what value of x, when we take the absolute value, will we get an output of 7? So what you should be thinking is, what value could I plug in to these absolute value symbols and get 7? Well, I could plug in 7, but if I also take the absolute value of -7, I would also get 7. So x must be 7 or -7. All right, the second equation. For what value of y, when I take the absolute value, will I get -16? Well, you might be thinking, well, if I take the absolute value of 16, or the absolute value of -16, then I would get -16. Well, let's try it. What is the absolute value of 16? How far is 16 from 0? Well, it's a positive 16. How about -16? That's also a positive 16. Well, if you notice, whenever we take the absolute value of a positive or negative number, our output always has to be positive. So this can't happen. We cannot get a negative number when we take the absolute value. So the second equation actually has no solution, or it's inconsistent. Alright, so here are the steps in solving an absolute value equation. First of all, we're going to isolate the absolute value, which means that all we're going to have left on one side of the equation is just the absolute value and what's inside of it. The second step is to make two equations. So we're going to set the part left inside the absolute value equation equal to the positive and the negative constant. So in an absolute value equation, we're going to turn this into two equations. The first equation is going to be the x minus 3, which is the part inside, equal to the positive 7, but we're also going to set it equal to the -7. And this represents what's in the absolute value. And in the absolute value, we could have 7 or -7. Once we have the two equations, we're going to solve them like we would any normal equation. Alright, so we get two values for x. We get 10 and -4. In order to be sure that our answers are correct, we're going to plug each value back into the original absolute value equation. So we're going to plug in the absolute value of 10 subtract 3. Does that equal 7? That's our question. And so we need to do what's in the absolute values first. So 10 minus 3 is 7. So the absolute value of 7 is 7, and that works. We're going to do the same with the -4. So here's our original. And I'm going to plug in -4, subtracting 3 from it. The absolute value of -4 minus 3, which is -7, is that 7? Well, it sure is. So we do have two solutions in this equation. X is 10, and x could be -4. I would like you to pause and try this one on your own. Okay, the two equations you should have wrote are 4y minus 1 equals 11, and 4y minus 1 equals -11. And then to solve both equations, y could equal 3, or for our second equation, we get 5/2, which is 2.5. And I'm not going to take the time right now to check those, but those both should work. All right, we're going to add that first step back in. And the first step to solving an absolute value equation is to isolate the absolute value. And so what you should notice is that we have this 3 in front of the absolute value and this subtract 4 in front of behind the absolute value. Both of those need to be removed to the other side of the equation. So I'm going to start with taking this negative 4 and adding it to the other side. And then this 3 is being multiplied by b plus 2 in absolute value, so I can divide the 3 out. And by doing those 2 steps, I've isolated the absolute value of b plus 2 to the left side, and it's equal to a constant of 1. Now that I have the absolute value isolated, I can go through the previous steps to split this into 2 equations. So I have b plus 2 equaling to the positive 1 and b plus 2 equaling the negative 1, and I will solve both of those. So I'm going to subtract 2 from both sides, so b equals negative 1. That's one solution. And I'm going to subtract 2 in the other equation, and I get negative 3. Again, I would check those. Let's plug in the first solution. So I'm going to go back to the original. I'm plugging in negative 1 for b. And then we need to use our order of operations. So we need to do what's inside the absolute value first. So we're going to do the negative 1 plus 2, which is 1. Now I'm going to take the absolute value of 1, and then I can do 3 times 1, which is 3, and subtract 4, and notice I get negative 1. So it does work. And I would go through the same process for the second solution. Alright, one last example. Notice how this one is different, and on the right-hand side, we don't just have a constant, but we have a 4x plus 5. The first step is still true. We still isolate the absolute value to one side of the equation. And notice that on the left-hand side, we only have an absolute value of 3x plus 2. And since that's isolated, we can go ahead and jump into splitting into 2 equations. So the first equation is going to be the 3x plus 2 equal to the positive of what's on the right. And the positive of that is just 4x plus 5. The second equation, however, is still the 3x plus 2, but that's going to be equal to the negative of what's on the right-hand side. So negative 4x plus 5. And you need the parentheses because what we're going to end up doing is distributing this negative 1. So I'm actually going to solve this equation first. So negative 1 times 4x is negative 4x, and the negative 1 times 5 is negative 5. All right, I'm going to move my 4x term to the left-hand side. Subtract 2. And I get x equals negative 1. All right, back to the other equation. I'm going to subtract my 4x over, so I get negative 1x plus 2 equals 5. I'm going to subtract my 2 over, and then divide by negative 1, so I get x equals negative 3. Okay, so here comes a caution. Whenever you have an absolute value that's equal to not a constant, and you have variables on the part that doesn't have an absolute value, you must check. Okay, we must check these answers. So I'm going to erase a minute and give myself some room. And over here on the upper right-hand side, we're going to check both of these solutions because we might get what's called an extraneous solution or a false solution. Alright, so plugging negative 3 in. So I have my absolute value 3 and x is negative 3 plus 2 in absolute values. Does that truly equal 4 times negative 3 plus 5? Okay, so let's simplify that. Absolute value 3 times negative 3 is negative 9 plus 2. And negative 9 plus 2 is negative 7, and absolute value of negative 7 is 7. On the other side, I'm going to do 4 times negative 3, which is negative 12. And negative 12 plus 5 is negative 7. And there's no absolute value, and then these are what I need to compare. And notice that 7 and negative 7 are not the same. So absolute value of negative 3 plugged in there is not a solution. And then we're going to do the same thing with this other one. So I'm going to erase my work here. And this time I'm going to plug in my negative 1. All right. So absolute value of 3, plugging in negative 1 for x plus 2, does that equal 4 times negative 1 plus 5? So inside the absolute value, I have 3 times negative 1, which is 3, and then I'm adding 2 to it. And negative 3 plus 2 is negative 1, and the absolute value of negative 1 is 1. On the other side, 4 times negative 1 is negative 4, and I'm adding 5 to it, and I get 1. And notice that in this case, I get a true statement, which means our only solution to this absolute value equation is negative 1.